Good evening, and welcome to Cosmic Chronicles. Tonight, we turn our gaze to the stars, where new discoveries are constantly reshaping our understanding of the universe. Our first story takes us to a distant, rocky world that has defied our expectations. For years, the exoplanet GJ1132b, located about 41 light-years away, was a source of great excitement. It's a super-Earth, a rocky world with a size and mass similar to our own, orbiting a red dwarf star. Early observations from the Hubble Space Telescope suggested it had a thick, hazy atmosphere, potentially a secondary atmosphere created by volcanic activity. This was a thrilling prospect. It implied that even a planet in a harsh environment, bombarded by its star's radiation, could find a way to regenerate its life-giving blanket of air. It gave us hope for finding atmospheres on other small, rocky worlds. But hope, it seems, can be a fragile thing in the cosmos. The James Webb Space Telescope, with its incredible infrared vision, was perfectly suited to study this intriguing planet. It could peer into the depths of its atmosphere with unprecedented clarity. The plan was to analyze the starlight passing through the planet's atmosphere to identify its chemical composition. But when the data came back, it was astonishing. The transmission spectrum of GJ1132b was flat and featureless. There were no telltale signs of water vapor, methane, or any of the other gases we expected to find. The conclusion? GJ1132b has no atmosphere. The planet is a barren, airless rock, scorched by its star. This discovery is a reality check. While a planet's size and distance from its star might seem promising, other factors, like intense stellar radiation, can strip away any chance of a stable atmosphere. It's a sobering reminder that the search for habitable worlds is a complex and nuanced endeavor. This ghostly planet, once a beacon of hope, now serves as a cosmic warning, defining the limits of habitability and challenging us to rethink what a potentially habitable planet truly means. Now, let's bring our focus a little closer to home, to our own planetary neighbor, Mars. For decades, the search for life on the red planet has been a story of tantalizing hints and frustrating dead ends. But a recent announcement from NASA's Perseverance rover has just added the most compelling chapter yet. The rover has been meticulously exploring the Jezero crater, a location believed to have been a vast lake billions of years ago. It has drilled into and collected samples from ancient mudstones in a region called the Bright Angel Formation, a dry river channel that once fed the lake. The samples, especially one nicknamed Sapphire Canyon, have now yielded a truly remarkable discovery. Scientists analyzing data from the rover's onboard instruments found something extraordinary: minuscule specks of minerals called vivianite and greigite. On Earth, these specific iron phosphate and iron sulfide minerals are often produced by the interaction of mud with organic matter, a process frequently driven by microbial life. In essence, these are potential biosignatures, a kind of chemical fingerprint left behind by ancient organisms. The rocks also contained traces of organic carbon, the fundamental building block of all life on Earth. The fact that these findings occurred in the specific chemical and geological context of an ancient lakebed makes them even more compelling. This is not a definitive proof of life, but it's the strongest evidence we've ever found. It's the clearest sign of life that we've ever found on Mars. According to acting NASA Administrator Sean Duffy, the minerals could have formed through non-biological processes, but the combination of organic carbon and these specific mineral formations in a formerly watery environment is a powerful coincidence. The final answer will have to wait. The most critical step is to get these samples back to Earth for in-depth analysis in our laboratories. Only then can we definitively determine if these minerals were formed by ancient Martian life. The Mars Sample Return mission, which will retrieve the samples collected by Perseverance, is our best chance to answer this question. Until then, These rocks from Jezero crater whisper a tantalizing possibility that billions of years ago, Mars was not just a desolate red rock, but a living world.